This is the front labeling head, and it's a pretty standard pressure sensitive labeling head. Doesn't matter who you buy it from. Pretty much what the specifications are. They're all going to be basically the same. And we start off with an unwind roll. This is the label roll. It sits on a plate, and this plate has a brake on it, so you can see it's a little bit hard to turn right now. But when we pull the labels forward, we're going to pull this arm to the front, release the brake. Now this spins freely. It's very important that this brake be in place and properly adjusted so that you maintain a consistent tension on the label web. Consistency of the tension is what's going to give you consistency of the stop position. You have a range of how much or how little tension you have, but the really key factor is that it be consistent. One of the problems I've run across in the past is the label core slipping on this shaft, so that even though the brake is working correctly and this plate is locked, the core itself will spin, causing you problems with the tension. So there's a couple ways to get around that. One is to take a label or two, put it inside the core to give it a little less inside diameter, a little bit tighter fit. A better way is to use an unwind axle that has a gripping mechanism to positively grip the core. As this machine does, you can see that core is not going to slip on the shaft. So we come out over a dancer roll, over a guide roll, over the brake, tension control, over another guide roll. There's a brush which provides a little bit of tension. This brush here is normally at the discharge or as the label is being applied to wipe the label down. We've moved it out of the way so you can see what we're looking at. The label web comes through, and here we have a capacitance sensor. Now most labelers are going to use a photo eye rather than a capacitance sensor. If you're using a clear label or a thin film label, you will need a capacitance sensor rather than a photo eye. Because this is a rental machine, it's built to be as universal as possible, so it comes with a capacitance sensor which works on either an opaque label or a clear label. The label feeds down to the peeler plate, and you can see the profile of the peeler plate. Some people will call that a knife edge. As the label feeds across the peeler plate, it's going to want to keep going forward while the web is pulled to the back. And I'm manually simulating it here. And this is an issue. I've now created some slack in the web, which is going to cause a problem later on. You notice that the label has drooped out of position, and we need to fix this before we snap the web and break it. So I'm going to remove that label manually. I'm going to pull the web back and retension everything. I'm going to trigger the photo eye manually, so if you watch what's happening at the label, that label would have been out of position because first it had to advance to take up that blank space, but this labeler is smart enough to know that there's a blank space and then re-register so that it stops in the correct position. The label itself goes forward. The web comes around to the back. It goes into a nip roller. The nip roller is a rubber roller with a tension roller. which can be opened so that you can rethread the labels. This is driven by a servo motor, and this turns on, pulls the label web forward until the capacitance sensor sees the gap between labels, and then turns off, stopping the label in the correct position. So this nip roller is what's actually controlling the application and the stop position for the next label. The nip roller itself, servo-driven, controlled by the machine PLC. The web, the backing web, comes out and is taken up on a take-up roller, which doesn't need any particular attention, just needs to accumulate the film or the backing web so that you can get rid of it. If this nip roller is open, or if somebody has sprayed it with WD-40, or if it's badly worn, it can slip. And what will happen when this slips is that the label will no longer stop in the correct position. It may slip enough to where the label doesn't dispense at all. Now on this labeler, on this setup, you can see that the label is extended past the edge of the peeler plate by about 1/16 of an inch. And different machines, different setups will require different extensions. This machine, the extension is set up electronically from the control panel. On some machines, it'll be set up by moving the photo eye or capacitance sensor forward or back. Once the position for this has been determined, it should be locked in place. Use Allen screws rather than hand levers or hand knobs, because if an operator can adjust this, they will. So you want to avoid adjustment so that the digital settings will always be correct. Now I'm going to increase the digital setting so you can see the effect at the control panel. Right now we're set on 3. I'm going to extend it quite a bit just for illustration. I've extended the label flag to 12. And here you can see it's now extended out about 3/8 of an inch. I can set it back to 0, and now it should stop flush with the edge of the peeler plate. And it did. On the chain aligners, we have 2 adjustments. We have one adjustment for height. We have another adjustment for in and out. You want the chain aligner to catch the bottle more or less at the center of gravity so that it doesn't tend to tip over as it goes through the aligner. You also want the 2 chain aligners set so that the bottle is centered on the conveyor. So your first setting would be the chain aligners. The bottles will then come into the top hold down belt. The only adjustment here is the height, which is around the back. And this has a locking pin, which is very nice to prevent the adjustment from vibrating out of position, and then a crank that turns the screw to raise and lower it. The supports are very rigid so that the belt itself always stays parallel to the main conveyor. Once the bottle is centered on the conveyor, centered by the chain aligner, centered under the top hold down belt, you'll need to adjust the position of the labeling head. There are a couple of adjustments that you're normally going to have to worry about. One is the height. This wheel here raises and lowers the labeling head to center the bottle vertically, center the label vertically on the bottle. A second wheel underneath moves the labeling head out and in, because you want the peeler plate to be as close as possible to the bottle. You don't want to touch the bottle, but you want it as close as possible to the bottle so that the label goes on smoothly. Now, if you adjust the in and out dimension, you may adjust the position of the label on the bottle. It's going to depend on the particular labeling machine and the particular bottle. So you may have to go back and adjust your forward and back position electronically once you do this. You also have a skew adjustment. And if you're getting labels that are skewed, they're not straight up and down oriented to the container, this is the problem. The labeling head needs to be perfectly level with the bottle. So this, I'm not going to make the adjustment, but by loosening this, you can adjust the tilt angle of the peeler plate. We have another adjustment here which allows you to adjust the labeling head this way. Normally the labeling head should be perfectly parallel to the conveyor. The conveyor should be perfectly level, the labeling head should be perfectly level in the lengthwise dimension. But occasionally you may want to put on a label that's skewed, or you may need to correct a skew in a label. This is the adjustment that you would use to correct that. The labeling head should also be perfectly horizontal relative to the conveyor, and if it's not, the peeler plate will be closer to the top of the bottle than the bottom, or vice versa. In the case of a tapered bottle, you will want it to be angled so that it's at the same angle as the bottle taper, and this is the adjustment for that. Now you notice that all of these have scales on them, so you have a numerical setting that you can set to. So scales there, scales here, and once you get the labeler set up for a particular container and label combination, you should write down all these numbers and keep them somewhere safe, because once you know those numbers, it becomes much easier to set up the labeler, even if multiple people are doing the setup, because they can just adjust the various parameters to a specific number rather than having to do it by guess.